Question states, calculate the work done in joules when 1 mole of H2O vaporizes at 1 atmosphere and 100.0 degrees Celsius. Assume that the volume of liquid water is negligible compared with that of steam at 100.0 degrees Celsius. Assume ideal gas behavior. So let's look at what we need to identify. We need to identify the work done in joules throughout this process, from H2O vaporizing, going from the liquid to the gaseous state. We know work is equal to the negative pressure times the change in volume. Well, let's look what's happening here. We're going from a liquid to a gaseous state, but the question is including the fact that liquid water has a negligible volume. So we know the initial volume of H2O is equal to 0. We know that the final volume is what we need to calculate. We need to find out, all right, well, what is the final volume when water is no longer in the liquid state but now in the gaseous state? So we're going to have H2O in the gaseous state, and we want to know what is the volume of this H2O in the gaseous state. We're also told ideal gas behavior. That reminds us we can use this equation. Given a pressure, number of moles, we have the ideal gas law constant, and a temperature, we can solve for volume. So we arrange it and we say that nRT is equal to P. Plug in everything we know. We're given 1 mole of water. We know the gas law constant to be equal to 0.821 atmospheres liter mole Kelvin. We know the temperature is that of 100 degrees Celsius, but convert that to Kelvin. So we're in the absolute scale, so 373 Kelvin, and we know a pressure of, again, 1 atmosphere. This is all going to be equal to 31 liters. The volume, change in volume, would be equivalent to the final volume, which is what we calculated. Now it's in the gaseous state, 31 liters, minus the initial volume, which was that of the liquid state, 0 liters, equals a change in volume equivalent to 31 liters. Now we can plug this information into our work equation. And we find that negative 1.0 atmosphere, and the 1.0 atmosphere times our change in volume is going to be equal to negative 31 atmosphere liters, which converted to joules is going to be equal to negative 3.1 times 10 to the third joules.